Okay, today we are still solving trig equations. And now these ones have different angle measures in them, meaning look at the first one. It's got a sine 2 theta in it, and it's got a cosine in it. That's not allowed. Okay, and there's no GCF here to try to take it out to get rid of it. So, sine 2 theta is the piece we have to change. And you have to look on your reference sheet for it, or go back in your notes if you don't have a copy of your reference sheet, and you see what sine 2 theta is equivalent to. If you're looking, sine 2 theta is equivalent to 2 sine theta times cos theta. And I'm going to rewrite the rest, which says minus cos theta equals 0. From there, I can actually solve this one. Now, even though there's sines and cosines still in the problem, I can take out a GCF here. The GCF between the first two terms is cos theta. When you take a cos theta out of the first term, you're left with a 2 sine theta. Out of the second term, you're left with a negative 1. From there, you split it and set them equal to 0. So you do cos theta equals 0. You do inverse cos and you get 90 degrees. You graph 90 degrees, which is a quadrantal angle. So we test the other side, which is 270. You type cos of 270 in your calculator, you see it does equal 0, so it works. So 90 and 270 are my two angles there. On the right hand side, we're going to add the 1, divide by 2, and we're going to do inverse sine of 1/2, and you get 30. We graph 30. 30 is in quadrant 1. 30 is also, or sine is positive there. Sine is also positive in quadrant 2. My red angles are reference angles. They're the same at 30. I want the black angle, which is 180 minus 30, which is 150 degrees. So 30 and 150 are my two there. And I'm done with that problem. Okay, that was not too bad. But let's take a look at the next one. Cos 2 theta. We got to change that. And this is where I was talking about in that other lesson, where you've got some options, and you got to pick the right one now. You got 3 options for cos 2 theta. The option you should choose for this particular case should only have cosines in it, because everything else in your problem has cosines in it. Okay? You don't want to pick anything with a sine in it, because that would just mess it up. So the only formula that has just a cosines in it for cos 2 theta would be 2 cos squared theta minus 1. I use parentheses just to show plugging in for that spot. I rewrite the rest. Because I see a squared, I'm going to set this equal to 0. So I'll have 2 cos squared theta plus 2 cos theta. Negative 1 minus 2 is negative 3 equals 0. I would try to factor it, and this one does not factor. So I have to use yesterday's method, which is the quadratic formula. Okay, so using the quadratic formula, it's going to be cos theta equals negative 2 plus or minus the square root of 4 minus 4 times 2 times negative 3 all over 2 times 2. So it's going to be cos theta equals negative 2 plus or minus the square root of 28 over 4. From there, we separate it into 2 problems. Negative 2 plus radical 28 over 4. And negative 2 minus radical 28 over 4. Take your inverse cos of both sides. Carefully type it in. Hopefully we're better with typing these in now. Round it to the nearest tenth. Because this isn't, we can't get a nice whole number, let's just say 34.6. We graph 34.6, which is in quadrant 1. In quadrant 1, cosine is positive. Cosine is also positive in quadrant 4. My red reference angles are equal. I want the blue angle, which is 360 minus 34.6, which is 325.4. For the right-hand side, we're going to do inverse cos of both sides. And you get undefined, you get an error. And so when you get undefined, you're done with that. And we have one more left. I will start it. You guys will finish it. So this one again has another cos 2 theta in it. Okay, so what we are going to do is we need to look for a formula for cos 2 theta. We've got 3 of them. We have to use one that has signs in it only because everything else has signs in it. So using the one that has signs in it, it's the 1 minus 2 sine squared theta. So I will have 5 sine squared theta minus 4 sine theta plus, and I'm using parentheses just to show plugging in. I'm going to combine like terms. So 5 minus 2 sine squared theta is 3 sine squared theta minus 4 sine theta plus 1 equals 0. This does factor. If you can't figure out how to factor it, please use the quadratic formula, but at this point I'm leaving you on your own. Also, please read the directions here. It says it wants it as a value between 0 and 2 pi. And express it in terms of pi if possible, but otherwise, if not, just give it to me to the nearest hundredth.